Okay, so I think we can start. Okay, it's already 8:41, so it's fine. So before starting, discussing topics from the course, just a quick look at the schedule. I updated the schedule just yesterday for next week. I will publish the slides soon. So today, that's the last lecture of the week. We had the Easter break, and we're going to talk about cross-site scripting, fetch APIs, and see some examples. But then, from next week, we will going to start talking about React. That is the framework on the client side that we will use to develop these single-page applications. And there will be lab as usual, so no different from let's say what has been planned in the beginning. So lab on Tuesday, just two groups. Just remember, but we already did it before the break, right? Before the Easter break. Okay, so unless there are questions, I think we can start. I know it's just after Easter vacation, so there are not so many of you, but we are recording the lecture, so there should be no problem in this regard. Okay, so before going to talk about the framework, how we simplify development of applications on the client side and so on, we'll spend a little bit more time on some aspects about the client side in general. Okay, so browser security in general. The browser is the application, the program that we use to use web applications. So we need to know limitations, how it can be tricked, how to avoid being tricked by websites and so on. Okay, so a few issues about this aspect. Okay, so we are basically with the browser, we are basically downloading code in any form from unknown sources, right? We navigate on websites. How can we make sure that this code that we are using is not malicious? Code in terms of JavaScript code, so really something that you can program, but also HTML code, CSS code, and so on. Okay, we call them code using code in a very broad sense. Okay, you don't have flow instructions in HTML, but you can specify behaviors. Okay. And so we will discuss the security implication of interpreting this code in the browser, and what has been done in the past, and how can we mitigate techniques that try to achieve behaviors which are different with respect to what the developer of the application wanted. Okay? So first we review the browser environment. So what does the browser do when it loads a new website? That for us it means a new application. Okay, so the browser asks the server, as the server responds with an HTML content, and the browser starts parsing the HTML content, right? So looking for tags, HTML, head, body, title, etc., all the tags, and creates the DOM tree. You remember the DOM tree, okay? While parsing the HTML, it happens that it encounters reference to other resources. We already saw some of them, like CSS. Okay, CSS is a link inside the head part of the HTML. And so it sees the link and goes to the web server or whatever place is specified in the link, and asks for an additional resource to be interpreted, in this case as CSS, but it could be, for instance, JavaScript code, right? We saw the script tag, script src, and you can provide JavaScript code yourself from your website, so code that you wrote yourself as a developer of the web application, but you can also download code from other resources online in the internet, as we saw with Bootstrap, right? Bootstrap came with CSS plus JavaScript, okay? Okay, we added that integrity check, so that hash, that at least made sure that what we downloaded is what we expected, but in general, we want to understand better how this mechanism works now, okay? And everything is repeated until everything, all the resources has been processed, loaded, and if it's code like JavaScript, they have been executed, okay? So they have been run. If they define function are defined. If they specify behavior, this behavior has been executed. Okay, and you know that the code in general, especially JavaScript, can read, write, and modify elements in the page, okay? And it can even access sometimes sensitive information in the browser environment, okay? So basically, we have JavaScript. We know how to create new nodes in the virtual DOM. In the DOM. Sorry, virtual DOM is from React. The DOM, the DOM tree. We can remove elements. We can change elements. So if an element says put your password here, put your new name here, you can change it into put your password here, okay? And things like that. So we can change everything we want inside the DOM tree, okay? And this implies that we can change everything in what the user can see in the browser window, okay? So in short, when we load something in the browser from a website, we as a developer of the web application, we would like to know and trust all the code that is being loaded by the browser, okay? Regardless of what it is, if it's either HTML, CSS, JavaScript, and so on, okay? We would like to have control about everything that is being loaded by the browser, okay? Otherwise, we might incur in what we call malicious behavior, so behaviors that are not expected by the developer of the web application and that typically leads to problems, okay? Any kind of problem can be just stealing information, can be privacy issues, or can be even damages, monetary damages, and so on, okay? So what are the classical problems that you can encounter in this situation? Well, they go under the name, the generic name of cross-site scripting, which is abbreviated as XSS, cross-site scripting, okay? The X is the cross, SS, okay? So this type of we can call them attacks, actually, because it's something that has been done by malicious actors that want different behavior from what the developer expects, okay? And these attacks are a type of injections, okay? We already talked about injection, talking about SQL injections, okay? But we can have many different other types of attacks, not just in SQL. And these injections are characterized by the fact that malicious scripts, so can be JavaScript code, very typical, but can be also HTML. We will see an example. You can do something with CSS as well. I mean, it's a bit cumbersome to develop because CSS is not really a programming language like HTML, but I mean, there are rules and instructions that can be crafted to achieve different behaviors from what we expected. And so malicious scripts are in some way inserted in the page being rendered, okay? Either on the website, so on the server side, or reflected back on the client side, and so on. We will see some of these types of attacks in more details in a few minutes. And since the browser does not expect this behavior, and especially it has no way to know that the script should not be trusted, okay? Because it loaded it from a trusted source. So what it thinks it is a trusted source. So the website I wanted to connect to. So you type www.google.com. Okay, you go to Google.com and you expect that everything that is on Google.com is not malicious. Okay, you wanted to go on purpose on Google.com. Okay, so there's nothing wrong in going on Google.com, but you're trusting what Google.com gives back to you when you access the website. Okay, of course there are a lot of restrictions. We already talked about these restrictions. Okay, the JavaScript code downloaded from anywhere, like Google.com, whatever you want, polito.it, cannot access local file system, cannot access a lot of information that is in the browser and so on, but still there are issues that can happen, okay? So the code is executed in the browser and can access sensitive information in the browser, such as cookies, tokens, secrets, and so on. Well, actually, it depends a lot on how we manage them, how the websites in general manage them, okay? And then what's the problem here? The problem is that it can take this information and send this information back to the attacker, okay? If somebody steals your session cookie, it can access all the information that the session cookie allows you to access on other websites, okay? It just sends the request together with your session cookie, okay? We will talk about session cookies later in the course. But I think you are, I hope, more or less familiar with this concept, okay? After you authenticate on a website, every request comes with a special string, a secret string that should be sent every time, and this is a sort of session cookie that basically tells the web server, I already authenticated, so I can access, I can do some operations that are typically not allowed if I'm not authenticated. And we said also that the code can even modify, rewrite page content, so it can manipulate the DOM tree, and so changing what is shown, and so basically tricking the user into performing actions that are maybe not wanted, okay, typically not wanted, okay? So it's a big problem. First of all, we need to understand how this works, and then how we can mitigate these problems. Actually, we never have really a definitive solution in security, right? So we can just try to mitigate the issues that arise over time. Okay, so before going into more details, maybe it's worth spending a few words on a sort of classification that has been tried by the OWASP. I think you can see something on this OWASP, which I invite you to take as a reference, as a good reference for going into more details about these issues that you might have in web applications. So we will follow more or less the classification proposed here. And the classification is based on two different characteristics. One is how the attack works, okay? So if it's a cross-site scripting, so-called reflected or stored or based on the DOM, so using the DOM, changing the content of the page, or another classification for the same type of attacks is where they happen, if they happen on the server side or if they happen on the client side, okay? So this helps us to understand where things happen, okay? So let's have a look at the first one. Probably the easiest one, okay, I would say. The so-called reflected cross-site scripting attack. So we have a website where our application is stored. We have a user, there can be more than one user, okay? We are just taking one user just because, I mean, this is the user that has been attacked by this attacker, okay? And you see the first action is that the attacker in some ways send something, a malicious string we say here, to the victim, that is the user, okay? This is the typical case when you receive a link on in an email, okay? They send you a link, or they share a link on a social network, WhatsApp, Telegram, whatever, okay? And you are tricked into clicking on that link. What happens when you click on this link? A browser opens, okay? That's a typical action when you receive a link and you want to visit the link, right? And so the user opens the link, which, of course, since it's a browser, it sends a request, an HTTP request to the server, okay? To the website containing our web application. And the server reflects the request, I mean, the server reflects the content, the malicious content that has been sent by the user that doesn't know that it's malicious. The server reflects this content back in the response because I mean, the server did, the programmers, the developer of the web server, the web application didn't think about this specific case, okay? So they took what they received and they reflected it back to the user, okay? For instance, in a page like search result, error message, and so on, page not found, the page named and the name that you sent, that you requested, cannot be found, okay? And then what's the problem? The problem is that if this system is well architected and the website didn't mitigate this issue, basically the browser is tricked into executing the malicious code, okay? Because it comes back from the website it wanted to access, okay? So it's not like it comes from another website. It would be easy to get, I mean, to detect this condition, right? But it comes from the same website you want to visit with the link. And so this code might do anything malicious, okay? So, for instance, can steal sensitive information and so on, okay? So just to be a bit more concrete, okay? Let's see an example, okay? So you have your application, myapplication.com, okay? And you have a URL, I mean, classic URL, an API URL, where you can do a search, maybe searching in the pages of your website, in the posts, in the answers, in the example we have, in the films that you have in the lab, and so on, okay? And you search for a page named script something, okay? Why? Because this is the link you received by the attacker. And of course, I mean, typical users don't read what is contained in the link. They just click on the link, right? Even us, I mean, if a link is like four lines, I mean, we don't really go there and see all the content, and maybe it's obfuscated and so on. So I mean, the point is that this link is malicious, okay? But this URL, this URL is used to access the website, and then the website says in the response, well, this is the HTML page you should visualize, and unfortunately, the page you requested, script and so on, was not found, okay? So that's the HTML that we received back from the server. Of course, this server could have done something more intelligent, so not reflecting back HTML scripts. That's a possible mitigation technique, okay? But let's say that nobody thought about this, okay? And so they just took what is written here as a parameter of the URL and reflected back to the user in a portion of the HTML, okay? This script something is interpreted by the browser because the browser receives a new page, a new HTML page, and interprets it as a new website, okay? As it does in the beginning. So looks for the text. If there is a script tag, it goes inside the script, looks for the JavaScript code, executes the code, okay? Of course, here we just have something simple because we need to fit things in the slides, and we want to be able to show something. Okay, so just alert is a function inside any browser environment that creates a small window with a message, in this case cross-site scripting, so this string, and I think with a button OK, just to close it. Okay, not recommended to be used at the exam. Okay. I mean, not the attack, of course, but we are talking about this alert function. It's just something which is very convenient, very easy to use to show something, to test something in the browser, okay? So that's the issue, right? So there are two problems, okay? So we had a crafted, a malicious URL, okay? And we receive it, and we couldn't do nothing. We cannot do anything about this. I mean, if somebody sends us an email, we get the email, right? I mean, the only thing we can do is put it into the spam. But if you are tricked into clicking this this link, and so accessing this URL. The issue is that the server should be programmed in a way that it doesn't reflect back all the content that it receives to the user. Okay, so going back here, so it comes back number 3, and number 4, the script is executed. Okay, so something malicious can happen. We don't really care about what. Okay, that's another topic probably for other courses, but I mean, it can steal information that's already enough. Okay. Okay, so that's one of the possible issues that we have with something that looks innocent, right? So it's just a URL, just for searching something into your website. I mean, how would you design this URL in a different way? I don't think there is a different way of designing this URL, okay? The point is that what you can do on the server to prevent this behavior from happening, okay? And this is just, it comes in a few minutes, okay? Before that, we see another variant of this cross-site scripting attack. The first was reflected, okay? So we need to send something to the server, and the server sends it back because we send it with the URL. A second strategy is to make this system permanent, okay? So it's the image is very similar to the previous one. Just we have an additional step here. There's a storage, so like a database or some places where we were able to store some malicious information. So basically every time users, so not just the user that clicked the link, but any user that accesses the web application retrieves some information, it is exposed to this kind of attacks, like, again, the script and so on, okay? Again, this script alert just to show something. So there is a first phase, number 1. The attacker injects into the vulnerable website something malicious, like a malicious script or something like this, which is stored by the website. Like you are on Facebook, you are on Instagram, whatever you want. You create a new post, okay? And you write some text, okay? That's a nice picture of my Easter holiday, okay? But in addition, you put something else, like the code that we saw before. Less than script, alert, whatever, okay? And if the web application is not very careful, just take this content and store it into the database. It's a new post. Okay, there's an image and there's some text. Let's store the image and the text. And then everybody who visits this page and wants to see the picture you took during the holidays with the text gets the picture plus the text. But if the text contains the code, if we are not careful, we have the same situation as before. So we embedded this text with this code inside HTML. And again, HTML is parsed and it's executed by the browser. If it contains code, the code is executed by the browser. So here the point is that the attacker at a certain point knows or just tries, okay? Tries to inject something into malicious into a web application, and then visiting the place where the malicious code has been injected, any user. So here, any user that is using the website and visiting that page unknowingly retrieves the malicious code, and the browser executes the malicious code. Okay? Why you shouldn't trust the code that you receive from the website you just visited? You opened facebook.com. I mean, just an example. I don't want to blame Facebook. It probably is safer than against these attacks. But I mean, you just visit your friend's blog, and why you should think there is something malicious? I mean, your friend is not an attacker, right? But somebody else maybe has managed to insert something into this blog, and you just retrieve this content, you get this content, you execute this content. I mean, your browser executes this content, and you are exposed to this attack, okay? So that's, I mean, similar in terms of example as the previous one. Just here, we don't have a URL, it's just the content at a certain point the application accepts as good content to be shown later, okay? Like a new post, a new article, a new content that you can add, okay? It's full of this kind of web application. Any content management system does this operation. It gives you a new page, create new article, something, you pass your text, or you type or pass your text, and then you get it back, and any user gets it back, because the purpose of the web application is to publish content, right? And the problem is that when the server sends the HTML code back to any user that requests the article in a forum, the post, and so on, okay? Because you have this code that gets interpreted and executed, okay? Of course, again, the web application should prevent people, I mean users in general, from posting something that can be dangerous. But it's up to the web application to prevent this behavior, okay? So this type of attack is called stored cross-site scripting attack because it is persistent. So once you manage to insert something in the database, either the administrator or some user with the permission removes the content, or it stays there, and every time the users access that content, the user is exposed to the attack. While the previous one, remember the reflected cross-site scripting attack, is not persistent, because it works only because you sent a specific request with a certain URL. So if you don't click again on the malicious link, you're not exposed the second time you access the same API on the server, because maybe you search for something else, it's not a script, and you're not exposed to any other problem. Okay? Okay, good. So, last example. Cross-site scripting attack, DOM-based. Okay? So, again, here we start with an attacker which sends a malicious string to the victim. Again, typically a crafted link, another link. The user sends the link back to the website, but here, differently from before, we don't need the website to answer back with something, because this link is also processed inside the JavaScript code in the web application that the user has already loaded. Okay? And so the point is that the JavaScript code or the original web application was not careful enough to check what it's doing, okay? In the sense that it looks into the URLs that is sending to the website to perform additional actions, okay? We'll see an example in a minute. So some unsafe action is done by the JavaScript code of the original web application that tricks this code into modifying the browser DOM, so the DOM tree, and so what is shown to the user. And the DOM triggered the execution of some malicious code, and of course, again, back to the previous point, code can do anything malicious, okay? Let's look at an example, because this is a bit more tricky to understand, okay? So let's have a look at the JavaScript code in the vulnerable web application. So let's assume that at a certain point you look for something inside a URL, okay? Like this hash part that is a sublink inside the same page. Okay, the hash sign here is used to separate the main part of the URL from the part that points to a specific subsection inside the link, inside the page. So. And again, well, we are quite, not so much fantasy, right? So our injection is always script alert. But I mean, the point is that the JavaScript code shouldn't look for this hash part and then use it to do something dangerous. Like in this case, document write user text. Of course, I mean, this is quite trivial to identify. I mean, document write is probably a function that you should never use, okay? It creates a new part of the DOM, starting from a string, and this part is parsed by the browser, so executed by the browser and so on, okay? So, I mean, this is just a minimal example to make it work, but at a certain point, it might happen that in your web application, in your JavaScript code, you have this kind of instruction. Maybe you didn't write it yourself, maybe it's just a library that you use that does this for some reasons, to simplify some behavior, or give you more flexibility and so on. And you don't even know that there is this document right inside your code, okay? And so this is an example where you click on a link, you send it to the web server. The web server probably ignores this part because, I mean, it's not, maybe it's not simply programmed to care about the part after the hash. But the point is that the JavaScript code on the client side wants to use this second part of the URL for some reason. We don't really know why, okay? Maybe it wants to store some information, but I mean, it's not, I mean, working this way is not safe, okay? Because I mean, it's not just your web application, it's not just your JavaScript code that creates this hash part of the links. You can have links where the hash part has been determined by some attackers outside because, again, you clicked on that link. And so that's a big problem, right? Because how can we make sure that we write safe code, safe JavaScript code? The point is that here, the malicious code is taken by JavaScript from a source that can be controlled by something which is external from the application, so by an attacker. Like, for instance, the window.location, okay? You see here, window.location. That's what is contained inside the URL. And anybody can type there in the URL bar, or anybody can send you a link. So everything is already prepared and it goes there into the URL bar and you take information from Windows location. That's just an example. If you click on the link, we'll do it in a minute, you see a list of problematic sources, okay? And second action that second item needs to be present to make the attack successful is that the data is passed to an element or function or something inside the JavaScript. We call it sync, that supports dynamic code execution. Which, of course, these are the most dangerous functions and you shouldn't use it. But as I told you, maybe you are not using them. But maybe some library for convenience, for simplicity, for flexibility using them. Okay? And you are not aware of this. So, for instance, you shouldn't use the .inner HTML. We saw it last time. Because what you put there is parsed and interpreted as HTML by the browser, even if it's a script. You shouldn't use the eval function, of course, the document write that is more or less like the inner HTML, and so on. Okay? There is a list of common things to avoid this problem. Okay? So basically, the point is that, I mean, we were expecting code to be executed, but not actually that code that the attacker gave us. Okay? So the sync was expecting something, but not what it was given. So I hope now this picture is more clear. So attacker sent this link. The link is sent, of course, because it's a link, but we don't care about the fact it's sent. Everything happens in the client. Everything is processed in the client through JavaScript, which has been written in an unsafe way. Okay? Okay, so just to give you an idea of these things, let's click on this list of common things. Okay? So links should work. I tested them a few days ago, so there should be no broken links. So sinks, well, sources and sinks, okay? So common sources that might be problematic because they can be controlled by somebody outside your web application are document, of course location, right? But URL, document URI, cookie, referrer, that is the website, I mean the URL where we are coming from when we navigate to a new page in the browser, okay? Window name, history, the history of the browser in terms of, again, the locations, local storage and session storage. We will not discuss about this in this course, but I mean these are small storages that can be used by web applications to store information, but you need to be careful because anybody can write inside this local and session storage. Index.db, again, it's a storage, just manages a database and so on. Okay? So basically, they're mostly links or something similar that can be accessed externally from the web application. And sinks that can lead to DOM-based vulnerabilities, where we saw the document write, the eval, and what was the other one? I don't remember. Inner HTML, of course. Okay. That's not in the list, but it should be somewhere else. Okay. Document cookie. Well, WebSocket, we're not going to discuss WebSockets and so on, but anything that can execute code, okay? Even just JSON parse, maybe, I'm not sure what you can do with the JSON parse, but maybe you can simply trick the application into believing that there is some additional data that is not present in the original content and so on. Okay? Of course, there are a lot of vulnerabilities so, of this type, and each one of them is slightly different. I think you can click on this and see, examples of what happens if you use one of these. Okay, oh, you see the inner HTML here, and so we need to focus on finding a way to prevent this type of attacks. Okay, mitigate at least these types of attacks. I mean, preventing them if we know how they work, but I mean, mitigate in general because there might be different ways in which they can be made, they can work and we are not aware of it, okay? So, avoiding DOM-based cross-scripting attacks, well, the simplest way is to avoid any problematic source and sink, okay? Just avoid them. Avoid them, of course, in your code and try to avoid them in the, check that the library that you use don't use them, okay? Or if they use them, make sure that what you pass to the library cannot create problems, okay? Like you cannot pass code and stuff like that. Okay, we come back to the other attacks in a few minutes, okay? So how to mitigate these attacks. Before that, I want you to look at these cross-site scripting attacks also from a different perspective. Because, I mean, it's not the classification we saw before, it's not like really a rigid classification, okay? So different types of cross-site scripting attacks can overlap, like the stored and reflected, okay? That's not that much different. Maybe you store it with the click, okay, on the malicious link, and then the next time you don't need to click on the link because in some ways you manage to insert it into the database, and so you get the malicious code just from the database, okay? Cross-site scripting attacks can also be classified or explained in terms of where they happen, on the server or on the client, okay? So server cross-site scripting attacks are basically all attacks that comes all attacks that involves untrusted data that comes from a server. Okay, so somebody has managed to trick the server into sending malicious code to the client. Okay, and so the browser simply executes what it received from the server because it believes that the server can be trusted. Okay, so this is probably a more, let's say, dangerous one, because the server blindly trusts the client blindly trusts the server. Okay, it's like you navigate to on Google.com because you believe, and the browser will believe, that everything that comes from there is safe. Okay, on Facebook.com and so on. That's why they tell you, I mean, try not to visit, websites which have bad reputation and so on, because they can contain a lot of these types of attacks. Okay. I mean, I'm not sure if the website owner knows it or not. I mean, we don't really care. But if we go on Google.com, Polito.it, we open and so on, we expect that they don't contain malicious code. Okay. Okay, client cross-site scripting attacks, and the point is that some untrusted data is used to manipulate the DOM inside the browser, okay? As we saw with the DOM-based cross-site scripting attack. Because we used a library that wrote code that was unsafe, okay? Like trying to execute code based on some content that was unsafe, okay? And the source of untrusted data can be the DOM itself or the server, okay? DOM itself, we saw it before. So we took it from Windows location, okay? Or can come from the server as well. I mean, we don't really know, okay? That link, that new link with the hash could have come from the server as well, okay? Somebody, of course, had to create this malicious link in some ways before we accessed it, before we were able to access it, okay? So now that we have, let's say, a good example of what cross-site scripting attacks are, and we also distinguish from the fact that they can happen on the server and on the client, how can we do mitigation? How can we limit the malicious effect of these attacks? Well, depending on where we are, client or server, there can be different strategies. For instance, let's start with the client. Well, first thing is only use safe JavaScript methods and functions, okay? Guidelines, I think they are OWASP, okay? So, just follow these rules, okay? Escaping and so on. We'll see some of them, okay? A lot of rules, we know, okay? But security is like this. I mean, guidelines and rules. The main point is that untrusted data must be treated only as text to be typically displayed, okay? So anything that arrives from an external source, is not generated internally by the application, must be treated only as text, so not as code. It must not be executed, never, okay? Never. Because you risk executing code that you don't want to execute, of course, okay? So, for instance, you get this script, right? Less than script, greater than sign. How can we prevent this content to be executed, but, I mean, be able to show it in any case? Because, I mean, if I'm on a, let's say we are in an application where we are teaching how to develop HTML. We cannot say to the user, well, please don't write HTML tags, right? I mean, this application becomes useless, right? Because how can you teach web applications, I mean, HTML and so on, without showing HTML tags? but I need to find a way to show HTML tags, even script tags, without, preventing that they are executed by the browser. And so there is a possibility, and that is this one, to convert sensitive characters, typically the less than and greater than sign, the ampersand, so this and sign, the quotation mark, the slash, convert them to HTML entities using the escaping. So HTML has the possibility to represent characters in different ways. And one way is to use this escaping system that starts with the end, and there is a predefined string or the ASCII code and so on. And in this way, the content is not interpreted as if it was a tag, or if it was a slash for a URL or a quotation and so on, but it's just something to be shown, okay? Something to be shown that will never be executed, regardless of what it represents. So same appearance, exactly the same appearance, but has no effect from the point of view of the execution of the code. So that's one good point, right? So, so everything that comes from an untrusted source should be treated only as text, and when you display them, if you need to display them as they are, and you cannot modify them and modify the content like stripping, eliminating some parts, but convert anything that can be problematic to HTML entities. There are libraries that can do this for you, okay? You don't have to do it manually. Actually, it's better that you don't do it manually. You know, that it's so easy to introduce programming errors in this context. And programming errors might have consequences, right? It might make your code exploitable by attackers. When you use DOM methods to create dynamic DOM elements, just use DOM methods and don't use other ways that might be more convenient, so that might short your development time, so in short, you should avoid all methods that internally requires to evaluate what you pass to the element, to the properties, to the function, and so on. Okay? So no inner HTML, no document write, no eval, and so on. And you saw the list before. Okay? And okay, we are full of links that says, okay, that tells you what is safe and what is not. At least on the basis of what is currently known. Okay, this OWASP website gets updated frequently with new, not really new attacks, but new information that might be useful. Okay, by people working in this field. Okay, there's a lot of people working in this field. So on the client side, we receive something from an external source, potentially from an external source. Just be careful and treat it only as text and never execute it. How to escape? As I told you, there are functions available for doing this operation. Unfortunately, not directly inside the browser, but there are functions inside the packages that you can use in your JavaScript code. So, for instance, this validator, which is, we already saw it, it was inside the Express validator that is based on this validator. And this validator has an escape method, and you see the result of this escape method when it's used on a string like this, the less than, the greater than sign, the slash, and so on. Okay? So you see the conversion. This is done automatically by this method. Okay? And the good thing is that if you use this function, you are escaping the string, then you can be sure that when you show it, it doesn't get executed as code, but it's just shown as it would be, as it would as if it was just text to be shown, okay? So basically this LT renders exactly as the less than sign. And this X2F, that is basically the syntax, I think, to give the ASCII value of the slash in hexadecimal format, okay, basically renders exactly as the character slash. Okay, this is also available as a method on the check that you already saw in Express Validator, because you think of the previous case, this stored cross-site scripting attack. Somebody wants you to store something in the database. Maybe before storing this content in the database, you want to escape it, okay? So it's very easy. Just call escape on the field that contains the content you want to store on the database, in the database, okay? And so you can store basically anything, and the attacker can send anything, and it will just be sent back to the browser, but since it has this format, it will not be interpreted by the browser, okay? Even though you pass it to a val document write in HTML or whatever you want, okay? They are just characters. Good. So that's one thing, escaping, just for showing. But escaping is not always possible, okay? Because in some applications, you don't want to escape things because you actually want to execute the code. This is just a very simple example, right? Everybody likes to do some editing in a visual format. Like you want to use a visual HTML editor that immediately shows the result, okay? You have a form, again, in a content management system, whatever, and you type, let's say, B, and it becomes bold. You type whatever else, and it just gets formatted, okay? And to format this content, you actually need the browser to interpret the tags. So you cannot just say, okay, we transform the text and a less than sign becomes LT and so on, because the browser doesn't recognize the tag, and so it doesn't apply the formatting, okay? And so how can we do something in this case that mitigates the attacks that we saw before? Well, actually, if the input is actually HTML code or some code that needs to be rendered, it must be sanitized before allowing the browser to process it. And again, there are good libraries that can do this operation. And of course, it means that something will not be available because we cannot really sanitize everything. We cannot sanitize JavaScript code because it's code. I mean, we should understand what's going on inside the code, and this is not possible with a simple library. Maybe AI one day will be able to do it, but I mean, we don't really, I mean, this is just a joke, but I mean, in short, any JavaScript code cannot be allowed, okay? But HTML is reasonably simple to sanitize in the sense that we know that some tags, are just formatting text, like we saw before. This B tag makes text bold, okay? Might not be so nice because we say, okay, do it with CSS, but I mean, it's really innocuous. I mean, something is either normal or bold, okay? Or you want to create a new paragraph, P probably is fine, okay? You want to put a script tag, that's not allowed, okay? But I mean, it's not so simple because there are attributes that can become dangerous even in normal text, okay? So there is this library which we recommend in case you need to develop an application directly in JavaScript from scratch, which is called DOM Purify, that basically remove all the dangerous HTML code from the string you pass to it. I think there is an example. Yes. Okay. Of course, you need to read a little bit of documentation and understand how it works and so on. So we just provide an example, but I mean, not really. I mean, we're not going to test this stuff in the lab, okay? But I mean, you can copy paste in this code and play a little bit. We will do. We will try an example of these things in the second part of the lecture. So it's already online. I already prepared everything because, you know, making these things work is more difficult the more the time passes, because of course browsers and you know, libraries and so on try to prevent as much as possible this behavior. So the example has to be prepared carefully to make it work, okay? So, but I have an example to show you. So typically you use this DOM purify on the server side, but I mean, it depends quite a lot. If you are developing a client-side HTML editor, as we saw before, as I told you before, maybe it runs on the client side as well. But I mean, we don't really care. The point is that at a certain point we detect the fact that HTML has to be sanitized, okay? And to sanitize this HTML, well, basically we pass a string, okay, and we get back a string that has been sanitized. For instance, in this case, hello there with B tag, that basically means bold. Okay, nothing has changed. It's fine. I mean, the library thinks everything is inside there is safe. Don't purify, sanitize, image, src/ on error, alert, and so on. And you get back img src/, and that's all. The on error attribute has been stripped, eliminated from the HTML tag, okay? Because it's deemed to be unsafe, because typically on something contains code, JavaScript code, event handlers, and so it cannot be considered safe in any case, okay? This is just taken from the example that we are going to see in the second part of the lecture, okay? Because you think IMG, of course, says SRC, but I mean, this link is just an image. It will be interpreted as an image, so we cannot just put JavaScript code here. I mean, it doesn't make sense. I mean, the parser of the browser that deals with images says, well, I don't recognize the image, that's all, right? And so we need places where we can put JavaScript code as attackers if we want something that works, okay? And so this library actually has been thought for the client side first, and that's why you need this JS DOM package to recreate a window, a sort of window environment on the server side, so you can basically pass it to this create DOM purify that gives you the object where you have the method sanitize, okay? I mean, but this is just a technicality, okay? This library DOM purify just as a function, but the problem is that function wants the window object that is typically inside the browser, and if you are on the server side to use it, you need to use a second library to create something similar to a window object of the browser. Okay, just to reuse the same library. Okay, they could have designed this library differently, like giving you a function that didn't need a window when you started, but I mean, they didn't do it. Okay, good. So what's the difference between escaping and sanitizing? I hope it's clear by now that having a slide that summarizes the differences is important, okay? So escaping makes the content harmless, but it leaves the content as it is, okay? So, the content is not interpreted, it is just shown, whatever it is, okay? So the tags are transformed to avoid execution, and all the symbols, spatial symbols, so slash, quotation marks, less, greater than signs, and so on, are just transformed. So you're safe to put it anywhere in your web page. The appearance is the same, so the content remains the same, it's just the browser doesn't execute it because it doesn't recognize it as HTML code. While if you want to sanitize content, that's a different story because you want to be able to execute the content, okay? And so you need to remove parts that can be dangerous, okay? So sanitization doesn't give you back the same appearance. It simply remove unsafe content. Like in this case, script, any script tag is completely removed because, of course, it's unsafe because the library cannot do if the code is safe or cannot know if the code is safe or not. So you see the same example as before. If it's escaped, the appearance is exactly the same. If it's sanitized, the appearance will not be the same, okay? Because P is interpreted as a tag, it's fine, it's a paragraph, and script has just been removed, okay? So just keep this in mind and think in terms of your application. Does your application need to keep the same appearance? You should escape. Does your application need to execute the code? Okay, you should sanitize the code. Okay, that's a choice. And you cannot have a sanitization that keeps everything, because it's against the purpose of the sanitization, right? Okay. Yes, so just a few more words about cross-site scripting attacks. So we have two libraries now. One can do escaping, the other can do sanitization. Okay? So we need to understand where we should use them, where the best place to use them. Well, of course, when you have some server output, so something that needs to be returned to the client, you should make sure that everything has been at least escaped, okay, if not sanitized. And this depends a lot on the context. If you are returning HTML code, okay, you need to escape the HTML. If you are returning CSS content, well, that's a bit more difficult, right? If you are returning JavaScript, everything should be quoted. I mean, it's not really forbidden, but if you include it into a string, it will be just interpreted as a string, so not executed by the client. And if you're returning a URL, just always use this encoding format with the percentage sign and the X value of the ASCII characters to avoid that things are executed as code. Okay, you remember the previous example, the example from which we started, the question mark, less than sign, script, and so on. Okay, you can use them, but just make sure that they are properly escaped. Okay, of course, I mean, I cannot summarize everything in just a couple of slides. Again, cross-site scripting prevention cheat sheet, and you see how long it is. I mean, depending on where you are, okay, what you are returning, HTML, attributes, CSS, JavaScript, and so on. There are rules to follow, which are, I mean, typically good enough to mitigate, I would say, most of the attacks, okay, if not all. Okay, so actually, most frameworks, since this problem is so common, most frameworks, including React that we are going to use, already mitigate this problem when we are using variables coming from the environment of the library. So we are writing code in React, and we will have parts of HTML, which we'll call JSX, okay, for React, but it's basically HTML where we can put variables, so parametric values inside some attributes typically in the HTML tags. And of course, if these variables contains dangerous content, that can be a problem, right? And since the frameworks know about the cross-site scripting attacks, every time we use a variable, they automatically check the content of the variable and make sure that they don't contain anything dangerous, okay? Typically, they escape the content, okay? So it seems that we don't care that much about these issues later on in the course with React and so on, but that's because most of the frameworks are already programmed to avoid this kind of issues, okay? Luckily, I would say. And in a certain sense, it makes life more difficult to show something that can be dangerous using this framework. But I mean, don't get this false sense of security because you are using a framework. The framework cares about all the potential issues, attacks that can happen, okay? So, I mean, just be careful yourself. Think always in terms of what you're returning and if it's safe or not. Maybe, I mean, do you want to trust an external library, an external framework for doing escaping when you know that you should escape content? Maybe do the escape yourself, and that's fine. That's better. Okay. Okay. Other advice. Okay, and then we see in the time. Other advice: input validation. You remember we had two libraries about APIs. One was about designing the APIs. The second one was a bit lighter. I mean, if you develop everything in the first one, it was about input validation. And anything that can be suspicious from the formal point of view or from the practical point of view, because, you know, the ID doesn't exist, it creates problems, it might create problems in your database, it goes outside what you commonly expect in this input and so on. It should be treated very, very carefully, okay? And it should be, in general, rejected as soon as possible. That's why we say we are expecting an identifier which is a number. If it's not a number, just don't use it, okay? Because you avoid creating problems later on in your code, okay? You, at a certain point, maybe you expect a number, you do maybe parsing to convert it to a number, the parsing crashes, create an exception, the code goes in another place, I mean the execution of the code jumps to another place where you didn't think it might fail because you always think there is a number and so on, okay? Just avoid this kind of situation as soon as possible. So reject anything suspicious as soon as possible. You're expecting the zip code, the Italian zip code are 5 digits, okay? If you get 6 digits, if you get something which is not a digit, I mean, just reject things, okay? Just make sure you reject things which are really not valid, okay? Because otherwise you cut out some users from your application, right? But I mean, in general, if something is expected to have certain format, something is expected to behave in a certain way, if it doesn't fit, reject it as soon as possible, okay? Like the name of a person should not contain HTML tags, right? I don't think you can go, when babies are born, you can go and register a name with an HTML tag, right, for the babies. So, I mean, this is really suspicious, right? So, if you get characters which are not expected, probably you should reject the input, and if you want to, you can inform the user, okay? Input was not accepted because, just be careful, don't reflect back, okay, the code or whatever, as we saw in the first type of attacks. But, I mean, just be aware of the fact that, I mean, you're not the only one in the world, right? There are people that have accents on the names. There are special characters, Chinese characters, and so on. I mean, you need to think in terms of specifications for this API, what is acceptable, what is not. I think you can accept, I mean, Unicode characters, but some codes may be not. I mean, like less than sign, the punctuation signs, and so on. Probably they don't make sense, okay? But it depends a lot on the application. That's why you are paid to develop the application, because you need to think in these terms, okay? Not sure if the AI can do that better than humans at the moment. Example number 2. Okay, you want to get some text fields with some HTML, that's fine, but either escape it before storing it, that would be the best option, or remember to escape it before returning it to the client. So you store it as it is, but you need to remember to escape it every time you return it to the client. Maybe it's better to escape it as soon as it enters the database, so you don't forget escaping when you return it to the client, right? Because you add a new API, it's a new developer, you didn't know what happened in the past, what the other developers did, and so it forgets to escape, and that's a problem, right? But if what is in the database is already safe, that's good, okay? That's better, I would say. So it's so simple, right? And so, I mean, just I mean, this slide could be summarized as just apply your common sense, okay? So try to make decisions that make sense, okay? So if something looks weird, probably it should be rejected. If something needs to be accepted, it should be stored in an armless format, okay? Good. Just a few slides, okay? And then so we have still a topic at the fetch, but it's quite small for the second part, and then we'll see the example. So what we saw here in practice. I mean, since this kind of attacks have became so common, okay, nowadays, basically there is a system inside the modern browsers to define a policy of what is acceptable or what is not in terms of execution of code or something which is similar to code like HTML and so on. This is called Content Security Policy, CSP. Okay, if you click on this, you have some documentation. This is a Mozilla Developer Network, but I mean, you know that modern application, modern web pages, modern web applications load a lot of resources, images, CSS, JavaScript, and so on, even from different origins. We already did it. Bootstrap, it's in a CDN somewhere, okay? It's not on our website. And so that's a problem, we said. The nice thing of modern browsers is that we can define a content security policy saying that images can be loaded only from certain web servers. Code can come only from certain web servers. Cannot be inline code. That's really important. We'll see in a minute. Audio, video, and so on. Okay, think about images as well. I mean, an image can just say, I mean, write your password here. Right? I mean, it's just an image. But I mean, users might be tricked into doing things that are not expected, right? So the nice thing about the content security policy, which is very, very easy to use because it's just a header in the HTTP or just a tag in the head section, is that it is enforced automatically by the browser since the first load of the page. And all the rest of the code that you are going to execute there on the same website needs to follow these policies. Does not require configuration of other web servers. We will see the course, which is another issue we will discuss later on when we have two web servers that need to interact. But here it's simple because you have a web server, you specify this header with all the policies, and that's all. The browser enforces the policies. Can mitigate cross-site scripting attacks, which exploits browser trust in the content received from the server, because it can simply say, even if it comes from the same server, you don't execute inline code, for instance, JavaScript code and so on, which is the typical way by which attackers exploit cross-site scripting. Right? We saw the script tag with some code. Never execute the script tag if it contains code. If it loads code, that's fine, but code is loaded came from the server. If it's inline, don't execute it, and so on. So why it's not always used? Well, because sometimes it might be complex to configure, especially if you have different web servers, data sources, and so on. Complex applications requests information from different web servers. The API web server, the web content web server, images, CSS, another API server depending on the type of requests you're doing, and so on. So it might become a bit complex to handle. But I mean, how do you use it? Well, I told you it's an HTTP header. So either we insert a new HTTP header in the response if we control the website, okay, the web server. For instance, if you have Express, there is this Express CSP header package that allows you to basically specify all the rules with a nice JavaScript object, and it is automatically transformed in all the HTTP headers that are needed in the response of your web server. Or you can even work without the web server. You can just add a meta tag, HTTP equipped content security policy, in the head section of your HTML document, and this is really great because many times you don't control the web server. Like if you have a CDN that distributes your content, it means that the CDN controls the web server and cannot configure a different web server for each one of the clients it has, okay? I mean, it can, but you pay a lot more, okay? And just modify your HTML document. The browser will read the head section before executing any content. You put it as one of the first instructions, and it's like you sent this header in the HTTP headers, okay? And so you can specify content where it can be taken and so on. With a special syntax, again, same website with all the information, all the I should say at a certain point, which are all the headers, all the instructions which are allowed, okay? How to specify it and so on. Okay, it's pretty long. So summary, and then we stop for the break. So in general, anything that comes from data sources that cannot be trusted, and we saw it's very wide set, like parts of the URL, because links can come from outside and so on, they must be treated as potentially dangerous, okay? And so, as soon as you can, you do validation, escaping, or sanitizing, if you need to execute this content, before storing it, hopefully, or anyway before using it, okay? And when you return something to the server, it's your responsibility as a developer of the web application. Make sure that everything that your web server returns back to the client is safe, okay? It has been escaped, sanitized, whatever, okay? Even if it's something that came from the same client, because we saw the tricks, right? So the click on the link or something that went bad on the client side, okay? And whenever possible, since nowadays it's many years that this is available, use this content security policy of the browsers because they can stop a lot of things that maybe you missed in the code, okay? Like inline JavaScript code and so on. They just say, well, okay, I can see it's code, it comes from your web server, but the policy says I cannot execute this code. I will not execute this code, okay? Of course, you need to be aware of this and just make sure you design your web application in a way that doesn't need this functionality, okay? So I think it's enough for now. We have the usual 10 minutes break. And in the second part of the lecture, we will talk briefly about how to load the information, the URL from the server, so with the fetch API, but very quickly, and then we will see the example with the cross-site scripting, what we can do to avoid it, and so on. Okay, if you have any questions, I'm glad to answer, otherwise we'll break for 10 minutes. Okay? Okay, so thank you.